At first glance, it might seem like a simple question. Why does water look clear when you pour it into a glass, yet takes on that deep, mesmerizing blue in oceans and lakes? To understand this fascinating phenomenon, we need to take a closer look at the unique properties of water and the way light interacts with it.
When you hold up a glass of water, the liquid appears almost perfectly transparent. This is because the glass contains a relatively small amount of water, usually only a few inches deep. In such a shallow layer, light passes through with hardly any interference. Most of the visible light spectrum, the range of colors our eyes can see, travels straight through the water, bouncing off the glass and reaching your eyes without much alteration. The result? Water in your glass looks clear and colorless. But the story changes dramatically when we gaze at the vast expanse of an ocean or a deep mountain lake. Suddenly, water transforms into a striking shade of blue, sometimes turquoise or even greenish, depending on the conditions. What causes this transformation? The answer lies in the science of light absorption and scattering. Sunlight, which appears white to our eyes, is actually made up of all the colors of the rainbow. When sunlight hits the surface of a deep body of water, something remarkable happens. Water molecules are especially adept at absorbing certain colors of light more than others. Specifically, water absorbs longer wavelengths, such as red, orange, and yellow, more efficiently than shorter blue wavelengths. As sunlight penetrates the water, the reds, oranges, and yellows are gradually filtered out, absorbed by the water molecules themselves. The deeper the light travels, the more of these warm colors disappear. What remains, and what is scattered back toward our eyes, is primarily the shorter blue wavelengths. This selective absorption and scattering gives oceans and lakes their characteristic blue appearance. But that's not the whole story. The color of water can also be influenced by what's in it. In some lakes and coastal areas, you might notice water looking green or even brownish. This is often due to the presence of algae, plant material, or suspended particles. Microscopic phytoplankton, for example, contain chlorophyll, which absorbs blue and red light but reflects green, giving some waters a greenish cast. Sediments carried by rivers into the ocean can turn the water cloudy or brown. The blueness of the ocean is also enhanced by the way light is scattered. As sunlight penetrates the surface, some of it bounces off particles and molecules in the water. This scattering process is more effective for shorter wavelengths, like blue, than for longer ones. This is similar to why the sky appears blue. Air molecules scatter blue light from the sun more than other colors. Another factor at play is the depth of the water. The deeper the water, the more pronounced the blue becomes. In shallow waters, sunlight can reach the bottom and reflect off sand or rocks, sometimes making the water look lighter, greener, or even clear. In contrast, where the water is deep and sunlight cannot reach the bottom, the rich blue stands out most vividly. It's also worth noting that the blue of water is not just a reflection of the sky, as is commonly believed. While the sky does lend some color to the surface, especially on calm, sunny days, the intrinsic color of water comes primarily from the way it absorbs and scatters light. So, the next time you marvel at the color of a mountain lake or the endless blue of the ocean, remember that you're witnessing the subtle interplay between light and water, a dazzling display rooted in the very physics of our natural world. What looks like a simple glass of clear water holds within it the secret to one of nature's most beautiful illusions.